Okay, guys. So today we're going to do section 6.2 and we're going to apply properties of rational exponents. So we're going to kind of build on what we did with rational exponents yesterday. Remember last chapter we talked a lot about exponent rules. Like if we multiply two things with the same base, what do we do with the exponents? We add them. Or if we take a power of a power, what do we do with the exponents? Power of a power, we multiply. If we divide two things with the same base, what do we do with the exponent? Subtract. Right. So a lot of those properties are going to come into play in this lesson. So here's our first one. If I multiply two powers that have the same base. Oh, it is. I'm so sorry. If I multiply two powers that have the same base, I'm going to add the exponent. So I'm going to have a to the m plus n. Now this is all variables on the property side. I'm going to work my examples with a number. And I'm going to do it with the fractions because that's the way that's going to be today. So we'll have a lot of fractional exponents just like we did yesterday. So that's why I went over fractional arithmetic before we started. So if I have 5 to the 1/2 power times 5 to the 1/2 power. Same base. They both have a base of 5. So we're going to add the 1/2 plus 1/2. What is 1/2 plus 1/2? 2 over, no. They already have the same denominator. Yeah, a half plus a half is one whole, isn't it? I'm adding them, so I need they already have a common denominator. So if I add the 1 plus the 1, I get 2 over 2, which is 1. Does that make sense? So it's 5 to the first power, which equals 5. Because a half plus a half is 2 over 2, which is 1, which is the same thing as 5. Next one is power of a power. So if I have a to an m power and I raise it again to an n power, I multiply the two powers. So with variables, it would be a to the mn. And with numbers, it would be something like 3 to the 5 over 2 squared. So what do I do when I take a power of a power? What do I do with my exponents? Multiply. So it's going to be 3 to the 5 over 2 times 2. Well, on the board over there, I have top times big divided by the bottom, right? Because this one is a fraction and this one is a whole number. So 2 times 5 is what? 10 divided by 2 is what? 5. So this is going to be 3 to the 5th power. And is 3 to the 5th power on your blue sheet? What is 3 to the 5th power? 243. Or we could have put that in our calculator with the rooftop. Okay, another exponent property. If we have stuff in the parentheses, here's ab to the m power. What do we do if we have more than one variable inside parentheses? Yeah, you give the exponent to both of them. So this would be a to the m power times b to the m power. So if I have 16 times 9 to the 1/2 power, that means both things in the parentheses will get the 1/2 power. So that's going to be 16 to the 1/2 power times 9 to the 1/2 power. Now, raising something to the 1/2 power from yesterday is the same thing as taking the what? Square root. So if I raise something to 1/2 power, it's the same thing as taking the square root. So what's the square root of 16? 4. Times what's the square root of 9? 3. And then you multiply 4 times 3 and get what? 12. We good with that? Okay, another exponent property deals with negative exponents. We went over one similar to this in your homework. What do we do with a negative exponent? So that's all in a numerator, so I make it 1 over a to the m power. So that's what it looks like with variables. Now let's actually work a problem. So if I have 36 to the negative 1/2 power, that means I put a 36 to the positive 1/2 power in a denominator. So that's the same thing as 1 over 36 to the 1/2 power. What is 36 to the 1/2 power? It's the same thing as the square root, right? So the square root of 36 is 6, so that's 1 over 6. Does that make sense? So negative exponents go to the other part of the fraction, and 1/2 means square root. Next property, dividing with the same base. What's the exponent rule for if I divide two things with the same base? I subtract the exponent. So this is going to be a to the m minus n. And that's all we can do to that one since it's variables and we don't know what the variables are. So let's say some with numbers. Let's do 4 to the 5 over 2 power divided by 4 to the 1/2 power. They have the same denominator, don't they? So we subtract, what's 5 over 2 minus 1 over 2? What's 5 minus 1? 4. So that's 4 to the 4 over 2, right, which is the same thing as 4 squared, which is 16. So if you simplify this already without showing this step, that's okay. Okay. Y'all see how that worked, y'all? Does everybody see how that went? 5 over 2 minus 1 over 2 is 4 over 2. Well, that reduces to just a square. 4 squared, 16. Just simplifying lots of fractions today. So the next one is when you don't have the same base in a fraction. Then you give them both the exponent. That's all you can do. So, for example, if I have 27 over 64, all raised to the 1/3 power, they both get the 1/3 power. So that's 27 to the 1/3 power over 64 to the 1/3 power. Now, raising to a 1/3 power is the same thing as doing what? Taking a cube root, right? Do we know what the cube root of 27 is, or can we find it on our blue sheet? It's 3. And what's the cube root of 64? It's 4. So 3/4 is that simplified answer. So that is just kind of a summary of all of our exponent properties. So we are going to do some examples now, some just examples. So that's just a little summary for you of everything for our exponent properties. And now we're going to start actually simplifying expressions. So example A, 7 to the 1/4 power times 7 to the 1/2 power. So what are we doing here? We're multiplying two things that have the same base. So we're going to add the exponents, right? Hang on. We're going to keep our base at 7, and we're going to add 1/4 plus 1/2. Now, if we need to, come over to the side somewhere. And so 1/4 plus 1/2, what's the common denominator? 4. So 1/2 is the same thing as what over 4? 2 over 4. And 1 over 4 plus 2 over 4 is 3 over 4. So this is 7 to the 3/4 power. Now, can we take a fourth root of 7? No. So this is our simplified answer. It will not simplify any further. Now, if you could take whatever root this denominator is of that base, then you can simplify again. Does that make sense? And since we can't take a fourth root of 7 and get a whole number, then we're done. 7 to the 3/4 power. Just leave it like that. All right. Six to the 1/2 power times 4 to the 1/3 power, all raised to the second power. So what do we do when we have a parentheses with an exponent on the outside? Right, we give everything that outside exponent, so we're going to give everything a square, and if they already have a power, what do we have to do? Multiply the powers. So we're going to have 6 to the 1/2 times 2 times 4 to the 1/3 times 2. What's 1/2 times 2? 1. So that's 6 to the first. What's 1/3 times 2? Top times big divided by bottom. 2/3. So that's, it's not a plus there, my bad. And 6 to the first power, we can simplify that. That's just 6. Can we take a third root of 4, a cube root of 4? No, we can't. So we can leave that times 4 to the 2/3. And that's all we can do. We can't do anything else. 6 times 4 to the 2/3. Okay. I'm going to scroll, y'all. Next one. 4 to the 5th power times 3 to the 5th power raised to the negative 1/5 power. So this is kind of the same setup. We have stuff in the parentheses and we're raising it to an outside power. So what's the first thing we have to do? Multiply all the exponents to the outside exponent, right? So it's going to be 4 to the 5 to the times negative 1/5 times 3 to the 5th power raised to the negative 1/5 power. That's a fifth, not a third. What's 5 times negative 1/5? Negative 1, because it's negative 5 divided by 5, which is negative 1. So this is going to be 4 to the negative 1, and the 3 has the same thing, so this is 3 to the negative 1. And what do we do with negative exponents? What do we do with negative exponents? I can't add them, they don't have the same base. No. You're close. What do we do with negative exponents? Erase the negative so they'll be positive?
Yeah.
No.
No, ma'am. No.
No, of course not.
We bet not.
What do we do with negative exponents, folks? I'm going to drink some Coke. That'd be a Coke break while y'all figure it out. What happens to negative exponents?
They cancel out.
No, they don't.
No, they don't. They subtract something. Multiplying.
We stick them somewhere.
Oh,
You move them to the other part of the fraction, right? Right? So those negative 1 powers are going to go to the denominator, right? I guess you can say you stick them where the sun don't shine. Whoa. So yeah, you move them to the other side of the denominator. 4 to the first and 3 to the first are 4 and 3, right? What's 4 times 3? So this is 112. Does that make sense? Okay. Good deal. So if you have negative exponents, move them to the other part of fraction. You too young. Okay, so fraction. 5 divided by 5 to the 1/3. They got the same base, right? So what do I do if I divide two things with exponents that have the same base? Subtract. Isn't that a 5 to the first power on top? Yeah. So it's going to be 5 to the 1 minus 1/3. Now what is 1 minus 1/3? 1 whole minus 1/3. It'd be 2/3, right? If I have 1 whole and I take a third away, I have 2/3 left, right? So 5 to the 2/3. And can I take a cube root of 5? No. So there's my answer. All right, we're not cha-cha. All right, I'm going to show you one like this, but we're not going to focus on one like this. Parentheses, 42 to the 1/3 divided by 6 to the 1/3, all squared. Now what they do here is a little weird. They say that since these both have a 1/3 power, you can rewrite this fraction as the whole thing to the 1/3 power and then squared. Y'all see that? It's kind of like they did it backwards. They said since they're both a 1/3 power, then it could have originally looked like this. Does that make sense? And then I can do, yes. So that's the whole point in that. The reason we go from here to here is because 42 divided by 6 equals 7. So it's 7 to the 1/3 times 2. And what is 1/3 times 2? 2/3. So it's 7 to the 2/3. And I can't take the cube root of 7, so that's your final answer.
Yeah.
Mm-hmm. Let's see. Let's mix them up now. Let's go back and grab all of them. Oh, that's 2 to the 3/4 times 2 to the 1/2. How do we do that? You add them. So it's going to be 2 to the 3/4 plus 1/2. I would come over to the side and work on that somewhere. 3/4 plus 1/2. What's my common denominator? 4. So 1/2 is the same thing as what over 4? 2 over 4. So 3 over 4 plus 2 over 4 equals 5 over 4. So the answer is Equal signs low. 2 to the 5 over 4. And it's okay that that's improper. We don't want mixed numbers. We want improper if we need to do improper. Can we take the fourth root of 2, though? I don't think so. So, there's my answer. How are we going to get good at this?
Practicing and doing it over and over and over.
Pencil to the paper and you practice. You can't just watch me, and you can't sleep, and you can't copy notes. You got to actually practice it. Just like me playing my piano, I'd be Beethoven by now if I'd practiced like I should. Telling on myself. 3 divided by 3 to the 1/4 power. Y'all tell me what I need to do. Yep. So it's 3 to the 1 minus 1/4. What is 1 minus 1/4? 3/4. 3 to the 3/4 power. I can't take a fourth root of 3. So there's my answer. Let me see. Let's do a complicated one. See if y'all remember how to do it. We did do one similar. See if y'all can tell me. Parentheses, 20 to the 1/2 divided by 5 to the 1/2, all cubed. Very good. So if they have the same exponent here, that means you can squish these two together. Does that make sense to everybody? If they have the same exponent here, you can squish these two together. So what is 20 divided by 5? 4. And we're going to skip a step. What is 1/2 times 3? 3 over 2, 3/2. Now can I take a square root of 4? Yes. So simplify again. So you take the square. Remember we do index is denominator. The base is under the radical, and everything gets raised to the numerator power. What is the square root of 4? And 2 to the 3rd power equals, try again, 8. So that one was extra fun because we could simplify. All right, let's move on along and do some radical properties. So far we have dealt with them as rational exponents. Now let's talk about more of radicals, because we haven't drawn any radicals. We've just did them to rational exponents, and that's the fractional exponents. So we talked about radicals, I believe, a lot in chapter, was it 4? I believe it was chapter 4. We did a lot of radical stuff. And we basically just dealt with square roots, right? So now when we're talking about rational exponents, we're doing bigger roots. Now we're doing cube roots and fourth roots and fifth roots and all the other roots. So if you don't see an index, you assume it's a square root. Did y'all know that? If you don't have a little number inside the radical on the outside on the left, you assume it's a square root. Okay, so I need to go ahead and say that because you will see some square roots on your homework without a number. So if it doesn't give you an index, assume it's a square root. Okay? So if we have the nth root of a times b, that means you can take the nth root of each separate radical. So there's one property. If you have two things multiplied together, you can separate them. And same way with a fraction, if you can take the nth root of a whole entire fraction, that means you can take the nth root of the numerator and separate it from the nth root of the denominator. So those are just some common properties with radicals. What's my last letter I did? H. Okay, so let's do some problems. Radical. Actually, it's the cube root of 12 times the cube root of 18. Cube root of 12 times the cube root of 18. Now, the rule for multiplying radicals is you can multiply outsides times outsides and insides times insides. Okay? So those are that 12 and that 18, both inside the radical. We can multiply those together. So y'all tell me what 12 times 18 is. Yes, so we're taking the cube root of 216. Look on your blue chart. Can y'all tell me from the blue chart what the cube root of 216 is? Is 6. And it's not plus and minus because it's an odd index. So if it was an even index, we would have to say plus and minus 6. Technically. But I'm not going to be a stickler for that on this lesson. So Ij, let's do a fraction. The fourth root of 80 divided by the fourth root of 5. So that means we can take the fourth root of 80 divided by 5. And what is 80 divided by 5, somebody? $16. So there's the fourth root of 16. And what is the fourth root of 16? 2. Technically, it should be plus and minus 2, but I'm just going to leave it 2. All right, this is where it gets a little bit more complicated. Cube root of 135. Now look on your blue chart at your cube roots. I need me a blue chart. Look at your blue chart of your cube roots.
135.
Is 135 on there? No. It is not. So what you want to do is you want to find a number that is in there that's a cube root that goes into 135. There's 216 to go into 135. Well, if it goes into 135, that means it needs to be smaller than 135, right? So, okay, looking at your chart, I'm just going to hold mine up here. 135 is between 216 and 125. Y'all see that on your chart? So work your chart backwards. Does 125 go into 135 evenly? Okay. So, way to be technical. Does 64 go into 135 evenly? You can check it in your calculator. Is 135 divided by 64 get you a whole number? No. Go up the next one. It's cube root of 27. Does 27 go into there evenly?
Yes, ma'am.
It does. So that's what we're going to use. Okay? So what times 27 equals 135? So you're going to break that into the cube root of 27 times 5. And what is the cube root of 27? 3. So the answer is 3 cube root of 5. You know when we simplified our radicals before, after we took the square root, we pulled it out? Same thing here, but we're taking the cube root. And after we take the cube root, we pull that number out. And we can't do anything with the cube root of 5, so we leave it in the radical. Does that make sense?
Yes, ma'am.
And I meant to make these red, so I'm going to fix that right now. Just to have my notes looking good for next year. And it's not working. I'll fix it later. All right, let's do another one very similar. The cube root of 104. So again, I'm going to look at my cube root chart over here. 104 falls between 64 and 125, right?
Yes, ma'am.
So does 64 go into 104 evenly? No. Does 27 go into 104 evenly?
8 does.
Does 8 go into 104 evenly?
Yes, ma'am.
8 times what?
8 times.
13? So 104 is the same thing as 8 times 13. So I'll say the cube root. I'm going to do that red again. The cube root of 8 times 13. And what is the cube root of 8? 2. Pull it to the outside. So my simplified answer is 2 times the cube root of 13. That's a crazy looking thing.
I swear, I thought it was.
No, it's just me. So y'all okay with those? Y'all think? So whatever your root is, you do that chart and you try to find the next one, whatever root that is, that goes into that number. Huh? Yeah, we're not done. You want to end like this? You want to end like this one? Let me find one in the book because you really don't want me making up these problems with my own self. La, 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 la. I find where I am though. Well, of course I can't find one now. You put me on the spot.
Oh, you ain't got to do it.
I'll do one for the homework though.
Oh, yeah. We'll just do it.
Okay, I just won't tell you where it is.
Yeah, so we can make sure we get done.
I don't want to do that one down the 6th Street. I'll do a big one. 4:30. Huh? Oh my, JK. It's because I skipped one in my notes on my paper, and that's why. Yes, I need to go back to kindergarten. LM. Okay, so let's do the cubed root. Make sure I'm doing the right thing now. The cubed root of 432. Big number. So look at your chart. 432 will go way down here between the 343 and the 512, right? It does. So you'd break that into the cube root 216 times 2. And what is the cube root of 216? 6. So that is 6 times the cube root of 2. So does that help you, JD?
Yes, ma'am.
All right. Very good. They're absent. So last thing we need to do is add and subtract. And then we're done with this stuff. Long lesson today. Radicals and roots. Now you treat adding and subtracting like you do like terms. Okay? If the same thing under radical is the same, then it's a like term. They call it like radicands. Okay? Radicands, radicantes. Right. All right, so if I have 2 times the 4th root of 10 plus 7 times the 4th root of 10. Both of them have a 4th root of 10, right? 4th root of 10 don't simplify, so you add the coefficients. So what is 2 plus 7?
9.
And you keep the same radical. The answer is 9 to the 4th root of 10. Yes, sir. Does that make sense to everybody?
No, like 100.
You make 100. Okay. So if they have them written as rational exponents instead, like 2 times 8 to the 1/5 power, plus 10 times 8 to the 1/5 power, all you have to do is add the 2 and the 10. Yeah. So it's 12 times 8 to the 1/5 power. Now 1/5 power is the same thing as the 5th root of 8, right? But if they give it to you in rational exponents, you can leave it in rational exponents. If they give it to you in radicals, you can leave it in radicals. Does that make sense?
Yes, ma'am.
So if y'all leave that just like that, I'm happy. One more example, my darlings. The cubed root. Ooh, that's ugly, right? 54 minus the cubed root of 2. They're not like terms, are they?
Nope.
No. But what do you do? If you have radicals that are not like terms, is you need to see if you can simplify any radicals. So, for one thing, we can't take the cube root of 54, can we? So, but we can look to see if 54 has a number that goes into it that's a cube. Does 8 go in 54? No, it goes in 54.
Yeah.
So look at your cube root form. I've lost my blue paper. Okay? So,
27.
is 27 going to 54?
Yeah, ma'am.
How many times? So this is the same thing as the cube root of 27 times 2. And what is the cube root of 27? 3. So it's 3 cube root of 2 is what that simplified to. And then you can bring down your minus the cube root of 2. Isn't that a 1 in front of there? So what is 3 minus 1? And they have the same radicals now, so the answer is 2 cube root of 2. All right, so that's really the end. So, y'all, we're going to get good at this by practicing. There's no other way. It's not like you look at it and you get it. You got to practice. And I'm going to end my recording right now. Have a good day.